Well, we have another question here. Factorize fully. Question B. We see a difference of two squares. If I start with question 1, here we have like n to the power of 8 minus 81. Okay. So what can we do? N to the power of 8 can be written as can be like to the power of 2 like that, because the idea is to have like a difference of squares. I'll already say n to the power, I'll already say put my power of 2 there and then write over here within the bracket I say n to the power of 4, okay, and then minus 81 is also a square number. It is a square of 9, so I can just say here minus 9 squared. Now that I have like 2 squares there, we can factorize this by saying this is equal to n to the 4, okay, applying this formula of the difference of 2 squares, n to the 4 minus 9 in the bracket, okay, and then n to the 4 plus 9. Now, we cannot say we fully factorize here because there's much to do, you know, n to the 4, and then 9 is also a square number. We can, n to the 4 can be written as n squared, okay, to the power of 2. Okay, I prefer to write it this way. In this case, I will introduce the square bracket, and then n to the 4, I'll write like that's n squared, and then that's n squared to the power of 2. That's equivalent to n to the power of 4. Earlier in the previous exercise, we did remind this law we learned in the previous grades. That says a to the power of m to the power or raised to the power of n is equal to a to the power of m times by n. Okay, so now n to the power of 4 can be written as n to the power of 2 to the power of 2, because when we times these exponents, we get the power of 4 there. Now, 9 is also a square number. We do that because we know that 9 is a square number. It is a square of 3, so we can just say 3 squared there, just like that, and then n to the power of 4 plus 9. Now over here, we can't really apply this formula. We can't really reduce n to the 4 or 9 because remember we said that there is no formulas for sum of 2 squared. Okay, this remain the same. It's still a squared plus b squared. So now this will be like that, and then where is this? Then this will be equal to n squared minus 3 in the bracket like that, and then n squared plus 3, applying the difference of 2 squares formula, and then n to the power of 4 plus 9. Okay. Now we can say we fully factorize. 3 is not a square number, so we stop there. Okay, we cannot factorize further. We stop there. You know, now for question 2. Now we're doing question 2. This question. The question says 12x squared minus 75y squared. Now we note that 12 here is not a square number. Neither is 75 a square number. So in this case, we'll then try to see if there is a way we can factorize. Okay, we can find the highest common factor between 12 and 75. It has a common factor, which is 3. So we can take 3 out as a common factor. Is there anything to take as a common factor here? No, nothing else. So we can just put 3 out as a common factor, and then we're left with 4x squared minus what? 25 y 25 y squared. 25y squared. Now let's notice 4 is a square number, 25 is also a square number. Then we can factorize this. We can write it like, you know, it's like it's gonna be like 3 open brackets, 4 square number is the square of 2. So we can say like 2 squared, x squared minus 25 is the square of 5, so 5 squared, and then y squared. Okay, the fact that this power of 2, we can write 2x to the power of 2. So this would be like 3. I use now square bracket. I prefer to write this way. We can write it as a 2x to the power of 2, okay? 2x to the power of 2 minus, and then over here again, the power is 2 there, and then we can say y, 5y power of 2, okay? Now, notice we have a difference of 2 squares now, because we have 2x to the power of 2 minus 5y to the power of 2, a difference of 2 squares. This can be written as now, we can write 3 open brackets 2x minus 5y close bracket, and then 2x plus 5y close bracket. Now we're done with question 2. Okay. Yes. Now question 3. We can do question 3 also. Over here, 81 a cubed minus 49 a b squared. Now we can see that 81 is a square of 9, so we can say 9 squared. But a cubed is not a square, this is a cube. So what can we do in this case? We can split it. It's like a times a squared. Okay. Now minus 49 is a square of 7, so it's like 7 squared. Okay, and then a, and then b raised to the power of 2. Now, is there any common thing here? We have a here, and then a there is a common factor, so we can take a as a the common factor out. So this will be like a, open bracket, close there, and then we will be left with 9 squared a squared minus 7 squared b squared. Now these, okay, can be written, can be grouped. Okay, so we will have like a open square bracket. This will be 1 power of 2 there, and another power of 2 there, just like 9a squared, okay, minus 7b squared. Now again, we have difference of 2 squares, so 9a to the power of 2 minus 7b to the power of 2. Now this will be a open bracket 9a minus 7b close bracket, and then 9a plus 7b close bracket. Okay. Well, similar way we will do question 4. Okay, over here I'll let you do that, so you can notice what is the common factor here, the factor, and then apply the difference between the squares. And this also, I think I'll let this and that for you to practice. 4, 5, 6. Now for question 7, maybe we will do question 7. Now let's do question 7 says a plus b to the power of 2 minus c squared. Okay, so this will be what? These are already difference of 2 squares. Okay, a plus b, it is to the power of 2 minus c to the power of 2. So this will be just, you know, a plus b minus c, like that, and then a plus b plus c, done. So the same thing will be applied here, because here also we already have difference of 2 squares. So apply the formula. Here also you'll have like difference of 2 squares. You know, 25 is like 5 squared. 16 is 4 squared, and then apply the difference of two squares here. I'll leave that for you to practice. Thank you. Please subscribe to the channel and like the video, and also share the video and hit the notification bell to see our whenever we upload a video. Thank you.